All right, so we've got the stall detection wired up here. So we'll go into more depth this time than the last video. We've got our ground going to our ground, right? That's being blocked by the transistor. And then that transistor, the middle pin, is connected to the resistor, to the blue pin going to 3. So when we, tell 3 as an output, it can, let the electricity flow. We can actually get the motor going. That's on and off. And I think speed. And then we have diode. That's just protecting the red to black so it doesn't dump it all back into the Arduino. It dumps it into the diode. Cool. 10 millimeter shunt resistor, just in between the 5 volt in. And then we have 2 signals, orange and yellow, going into analog. Those are just detecting the voltage at the 2 different points on the resistor. Super cool. The code is designed to, if it feels resistance, it's gonna stop when it uses too much power. There we go. Took a little bit, but then it'll stop. It'll try again, so we'll hold it. You can. It's kind of trying. See, and then still doesn't go, and then we can. And it restarts. It's much easier when you can see the serial plotter, just to see the average power use. When it hits above 500 is when it stops. And then you'll see the average go back down to 0 and it'll try again. There you go. Code is fairly simple. We just have all of our constants set up. Those are our orange and yellow wires. That's our blue wire. These are just some values. Same here, same here, same here. Okay, yeah, all these are just values that are constants, like conversion and shit. We've got serial begin. Set the speed pin, the blue wire, going into the transistor as an output. And then we're also going to write the motor to be set to motor speed, which is up here. So it starts at full power, basically. Then what we have is we're converting the inputs that we're getting from the orange and yellow wires, and we are converting them to voltages using the constant. Run down the equation, just V in minus V out over the R1, and then multiply it by 1,000 to get milliamps. Power is just current times V out, because V out is the power consumption of it. So then what we have is we just have an if statement. What we're doing here is just averaging it. The serial prints, those are what gets spun out above. And then we're also just saying if it gets above 500 milliwatts, it needs to stop. And then if it's, under 500, it can go. Super simple. We can plug it back in and we can see the serial plotter a little better. So as you can see, we have V in, or V out, excuse me, our current, our power, and our average power. The stall detection is based on average power, so it gives it a nice delay. But yeah, you can see it. Once I hold this, you can see the voltage drop, which means the motor is consuming more. And then you can see the current increase, you can see the power increase, and then you can see the average power. Once it hits 520, it stops, so those zeros, the motor isn't running, it's not getting anything, and then it does, it updates again, and we go right back.